Hello everyone, thanks for coming. Today we are going to do a review of our week 9 lectures. So first, we introduce the polar coordinate in the plane. For every point on the xy plane, it also has a polar coordinate r theta. So r is the radius, r squared equals to x squared plus y squared. Theta is the angle, theta is arctangent y divided by x. In other words, x equals to r cosine theta and y equals to r sine theta. Then we can define the polar rectangle in the r theta coordinate. Theta in the range alpha to beta and r in the range a to b. The variable transform is dx dy equals to r dr d theta for integration. That is to say, the integration of a continuous function f of x and y in the polar rectangle r is equals to the value of this iterated integration. Integrating over theta from alpha to beta and then integrating over r from a to b, f r cosine theta, r sine theta, r. So here the integrand is f r theta, r cosine theta, r sine theta times r. Don't forget the small r here. Next, we introduce the definition of triple integrals. Triple integrals are defined for functions of three variables. It is defined using the limit definition. The triple integral of a function for a rectangular box equals to the limit of the Riemann summation fxy I y I z I times the volume of each sub-rectangular box delta vi. The union of those vi is the rectangular box R, and their intersections are the empty sets. We have the Frobenius theorem for continuous functions, which states that if f is continuous on R, then the triple integral, the value of the triple integral equals to the value of the iterated integration. First, we integrate over x, and then we integrate over y, and then we integrate over z. So for a general domain E and an enclosing box B, which means that E is contained in B, we define the integration of f on E to be the integration of capital F on B, where f is defined so that it agrees with f on E but is 0 for points in B minus E, outside of B but in B. Suppose the general domain E satisfies for every x and y in D, Z is in U1 xy to U2 xy, then we call E to be a type 1 domain. So here D is a domain in the xy region. In this case, we can express E as xyz, xy in D, Z from U1 xy to U2 xy. That is to say, given a pair of x and y, we can determine the range of Z. So with this type 1 domain, we can convert. So here D is a type 1 domain in the plane. With the type 1 domain in space, we can calculate the iterated integration on E. So the triple integration of f on E, suppose f is continuous, is the iterated integration. We first integrate over x from a to b, and then for y, because D is a type 1 domain in the plane, the range of y is t1x to t2x, and then given x and y, the range of z is u1 xy to u2 xy. And the integrand is fxyz, so we convert the triple integration into the iterated integration. And this is how we generally calculate the triple integration in practice. Thanks for listening.